Question 20.2 is another question that deals with the nomenclature of aldehydes and ketones, except for this time we're given the name and we have to come up with a structure. I always find these ones a little bit simpler. So let's take a look at A. It says S,3,3-dibromo,4-ethyl cyclohexanone. So the first thing that I would start here is I'd say, well, I know I have a cyclohexanone, so I would know how to draw a cyclohexane. So if I just draw a cyclohexanone, it's going to look something like this, if it's cyclohexanone. And then I could number it, and it doesn't matter which way I start. I could say 1, 2, 3, 4, 5, 6 carbons. So I have all my carbons numbered. Okay, so I'll just delete those for just for ease of putting substituents on the molecule and keeping it clean. But that's how I'd number it, like this. So if I say that I have 3,3-dibromo, I wouldn't have to worry about stereochemistry if I have two groups that are identical on the same carbon. So I don't have to worry about any stereochemistry here. And then we have a 4-ethyl group. And the 4-ethyl group is the only group that can have any stereochemistry, and the stereochemistry of the group is S. So we make sure that we put a wedge down like this, and if we draw another carbon here, so we have 1, 2 carbons off of the fourth carbon, so this is an ethyl group here, and you can see clearly that the stereochemistry is S at that carbon, so this is the right structure. This is going to be S,3,3-dibromo, so here's our 3,3-dibromo, 4-ethyl cyclohexanone. Okay, so let's take a look at the next one. So let's take a look at B, which is 2,4, so it's 2,4-dimethyl-3-pentanone. So I see the root here, I see the parent, which is pentanone, and I know that the carbonyl from the ketone must come at carbon 3. So if I draw a 5-carbon chain, so if I have 1, 2, 3, 4, 5. So this would be pentane if I put a carbonyl to make a ketone at carbon 3, so that's in the middle. Then I have 3-pentanone, but I have 2,4-dimethyl. So if I number my carbons like this, like 1, 2, 3, 4, 5, if I were to number them that way, then I can just install my methyl group. So on carbon 2, I'll put a methyl group here, and on carbon 4, I'll put a methyl group here. So now I have my 2,4-dimethyl substituents. And I don't need to worry about any stereochemistry here because we have two identical groups on both of these carbons, and the molecule is symmetrical, so the carbon I was referring to is this one here. So we don't really have to worry about, or we don't have to worry about any stereochemistry here, and that will be our final compound, 2,4-dimethyl 3-pentanone. And let's take a look at the very last one, which is R,3-bromobutanol. So we see al, we know that we're dealing with an aldehyde. So butanol. So if I was to draw out a 4-carbon chain to give me a butane, so if I draw 1, 2, 3, 4, I know that on my 4th carbon, I'm going to have, or on my carbon number 1, I'm going to put my aldehyde here. So like I said, when we talk about the nomenclature of aldehydes, the carbon that has the aldehyde, the carbonyl for the aldehyde will always be carbon number 1, 2, 3, 4. So that's how I'm going to number my carbon chain. That's the correct way to do it. So I need to put on a 3-bromo group, and I need to make sure that I have R stereochemistry. So if on my 3rd carbon, so this is carbon 3 here, if I put a wedge like this and I put a bromine at the end of it, that's going to give me R stereochemistry here, R. So this is the correct molecule. This is going to be R,3-bromobutanol. And again, like I said, I find these ones a little bit similar, or a little bit easier, a little bit simpler than ones where you're actually given the structure and you have to come up with a name. But I hope this will help you in your efforts towards learning how to name or how to draw aldehydes and ketones when you're given the name.